Welcome to This Explainer. Today, we're going to decode something that happens around us literally every single second of the day. We're talking about the invisible math of motion. Whether you're just commuting to work, going for a quick run, or flying across an entire continent, there's this hidden calculus governing exactly where you are and when you're actually going to get to your destination. We're taking those abstract numbers and turning them into real, practical tools you can use. So get ready, focus in, and let's unravel the math of movement together.
Picture this. You're settling in for a classic road trip, traveling from the bustling heart of Lagos all the way to Ibadan. You're just looking out the window, watching the landscape roll by. But here's a practical question for you. How do you actually calculate your true speed on that journey? I mean, you know how long you've been sitting in the car, and maybe you know the total mileage from a map. But how do you figure out the exact math behind how fast you're really moving over the whole trip? Well, that is the exact puzzle we're going to solve today.
Okay, let's dive into this. Section 1, the magic formulas.
To solve any travel puzzle, well, we need the right tools, right? We have three core equations here, and they're essentially just three different ways of looking at the exact same relationship. They connect the absolute fundamental pillars of motion. If you want to know how far you've gone, distance equals speed multiplied by time. If you want to know how fast you're going, speed equals distance divided by time. And if you need to know how long a trip will take, time equals distance divided by speed. These three equations, they are literally all we need to conquer any travel scenario today. They're your ultimate mathematical toolkit.
Section 2, interstate speed. For this one, we're taking the bus.
So, we're going to start the first leg of our mathematical journey on a long-haul bus trip right across Nigeria. Here's the specific scenario. An interstate bus travels from Lagos to Ibadan, and it covers a distance of exactly 120 kilometers. Now, if this journey takes exactly 2 hours from start to finish, what was the average speed of the bus? I want you to mentally highlight those key details for a second. 120 kilometers of distance in 2 hours of time. We've got two pieces of the puzzle. We just need to find the third.
All right, let's hear our options. Could it be A, a leisurely 50 kilometers per hour? Is it B, 60 kilometers per hour? Maybe C, a flying 240 kilometers per hour? Or D, 122? I'm going to pause for just a second here. Use your mental math. What do you think the answer is?
Okay, let's walk through the exact steps to solve this together. Step 1 is choosing the right tool from our toolkit. Since we want to find how fast we're going, we select the formula speed equals distance divided by time. Step 2, we plug in our known variables. We know the distance is 120 kilometers and the time is 2 hours. Step 3 is just the calculation itself. We simply divide 120 by 2. Notice how perfectly the magic formula just fixes the puzzle for us.
And the big reveal, it's 60. Answer B, 60 kilometers per hour. This brilliantly illustrates how average speed works, because even if the bus sped up to pass a truck or slowed down for traffic, on average, it was moving at a constant rate of 60 kilometers every single hour.
Moving on to Section 3, total distance. It's time for the bicycle.
Let's slow things down just a bit. We're shifting gears from a massive interstate bus to a more local, human-powered form of travel. Here's our next scenario with Chidi. He rides his bicycle at a steady, average speed of 15 kilometers per hour. He keeps this pace up, riding continuously for 3 straight hours. So what total distance did he cover? Once again, focus on what we already know. Our variables are his speed, 15 kilometers per hour, and his time, which is 3 hours of travel.
Now what's really interesting about this slide is that our options look quite different from the last problem, right? That's because we're solving for a completely different variable. We aren't looking for speed anymore. We want the actual length of the journey itself. Is the total distance A, 5 kilometers, B, 18 kilometers, C, 45 kilometers, or D, 30 kilometers? Take a guess.
Let's break down the math step by step. Going back to our toolkit, we need to find distance this time. So we select the formula, distance equals speed multiplied by time. We take our known variables and plug them right in, 15 kilometers per hour and 3 hours. When you multiply a speed by the time spent traveling, the hours actually cancel out, leaving you purely with the distance. It's just 15 multiplied by 3. Which brings us to a very satisfying answer of 45, option C. In 3 hours, Chidi managed to cover an impressive 45 kilometers on his bike.
Section 4, tracking time. We're getting in the keke.
Let's keep the momentum going. For the third leg of our journey, we're going to hop into Akika Nepe and navigate some city streets. Here's the problem.
A Keke Nefe travels a total distance of 40 kilometers. It manages to maintain a super steady average speed of 20 kilometers per hour throughout the trip. The question we have to answer this time is, how long does the journey take? Highlight those facts in your mind. 40 kilometers of distance to cover and a steady 20 kilometers per hour speed. I want you to play along again. Think about the options here and pick the right one to find out exactly how long this tricycle ride took. Are we looking at A, 2 hours, B, 4 hours, C, a rather exhausting 80 hours, or D, a super quick 30 minutes? What's the math telling you? Let's move to and see how this builds. We need our third and final formula to find duration. Time equals distance divided by speed. Plugging in the numbers we know gives us 40 kilometers for the total distance divided by a speed of 20 kilometers per hour. We just execute that quick division of 40 divided by 20, and that reveals our correct answer. Option A, exactly 2 hours. Think about it. If you need to cover 40 kilometers and you clear 20 of those kilometers every single hour, it will obviously take you exactly 2 hours to complete the trip. It's so deeply logical once you apply the formula.
Section 5, the final sprint.
All right, we've taken a bus, a bicycle, and a Keke. Now it's time for the fastest leg of our math journey, handled entirely on foot. Listen to the shift in scale here. A sprinter runs a 100-meter race in just 10 seconds. What is the sprinter's average speed? Notice how we've completely dropped down from the huge scale of kilometers and hours to the immediate, lightning-fast scale of meters and seconds. A 100-meter dash in 10 seconds. Here is our final set of multiple-choice options. I really encourage a quick mental calculation from you here, just like the sprint itself. Is the speed A, 1,000 meters per second, B, 90 meters per second, C, 5 meters per second, or D, 10 meters per second? Let's run the numbers really quick. We're solving for speed again, so we use distance divided by time. We take our 100 meters, divide it by our 10 seconds, and run the calculation. So, the crucial point is, the exact same magic formula applies beautifully even though the units have completely changed. The laws of motion, they remain constant whether you're taking a long road trip or running a short, fast race. And here is the final big reveal. Option D, a blazing 10 meters per second. That means every single second that ticked by, that sprinter covered 10 whole meters of ground.
Wow, we have really covered it all today. From solving for speed, to uncovering total distance, to calculating exact travel time. These three formulas, distance equals speed times time, speed equals distance over time, and time equals distance over speed, they are incredibly powerful tools. They literally let you peer right under the hood of reality and see the math that makes movement possible. So I'm going to leave you with this final thought to ponder. Next time you travel, whether you're hopping on a bus, riding your bike, or just walking down the street, which magic formula will you use to decode the hidden calculus of your own journey? Bring these concepts off the screen, take them out into the real world, and start calculating. Thank you so much for exploring with me today. Keep learning, and I'll catch you next time.